to everyone present here. Myself, Nahalakshmi, Assistant Professor of ECE Department from Sri Sanbha College of Engineering and Technology. Today, we are going to discuss about the real-time operating system. First of all, what is meant by real-time operating system? So, real-time operating system is a special type of operating system. It is designed to process the data and respond the events within a strict time limit. So the time limit is very important for this real-time operating systems. So for examples, airbag systems in the car and pacemakers in the medical devices, then industrial automation machines. So if the system responds too late, so even by milliseconds, so it may cause us serious failures. So we have to avoid this. Therefore, the real-time operating system, that is RTOS, is designed for the time-critical applications where meeting deadlines is extremely important. Some general operating systems such as Windows or Linux focuses on the predictable timing and fast responsible and reliable executions. So especially for utilizing this real-time operating system is reduce the failures in the previous systems. Then the second part, so what is RTOS? That is a real-time operating system is designed for a time-critical applications and ensures tasks meet deadline. So it is that manage the hardware parts, resources and application programs while guaranteeing that the tasks are completed within a specified time constraints. So the main goal of the RTOS, that is the deterministic behavior. The system can predict exactly how long a task will take a execution. For example, if a sensor detects some specific signal to convey the particular time to execute the performance. Here I shown some images to sense the accurate level of the task, that is your applications, and it will be conveyed to by using some devices, that is device drivers that can be used for communicating from one place to another place. So the operating systems for the real-time applications and focuses on deterministic responses. So in addition, some RTOS focuses on minimal delay, fast response, and at the same time efficient task scheduling. So these are to make the RTOS is very important for embedded systems. And some key features of the RTOS, first of all, the deterministic behavior that ensure that operation happen within the predictable time limits. For example, if a task run every 10 milliseconds, the RTOS guarantees it. Okay, the time limit is the very important in this RTOS, that is deterministic behavior. Then the second part is your fast interrupt responses. Now, for example, if we are taking the sensor part, so it will detect the environment, or if it detect the particular applications, it's very easy and very quickly to respond. And emergency stop in machines. So these are some examples for the fast interrupt responses. And then the third part is priority scheduling. So priority based scheduling, that is the tasks are assigned different priorities. For example, higher priority task get executed before the lower priority task. So this is these are all based upon the selection of our application and the selection of the task. So which task, when it is give the output and when it is executed. So the priority is the main part. So priority scheduling is one of the key features in real-time operating systems. Here I have shown the three types of real-time operating system. First of all, hard RTOS, firm RTOS and soft RTOS. Generally it can be classified into two types, And the special part is the firm RTOS. I will explain the part of firm RTOS. First of all, hard RTOS. So hard RTOS guarantees the deadline must always be met. For example, aircraft flight control system and medical life support system and a nuclear reactor control. So these are some real-time examples to understand the hard RTOS part. So in these systems, even a small delay is unacceptable. So the every time and every part will be notified and can be controlled in hard RTOS part. And firm RTOS, so occasional deadline misses are allowed. Some consideration present in this firm RTOS. So, but frequent misses reduces system performance. For example, some multimedia systems and the data acquisition systems. So, these are some examples of firm RTOS. Then, soft RTOS allows deadline misses without catastrophic failure. So, the system performance may reduces but it continuous functioning. For example, video streaming, online gaming, and mobile applications. So these are some examples of your soft RTOS. Next, we move to the RTOS architecture. The main part is the kernel part. So the core part of RTOS. Generally, the kernel is the specific backbone of the architecture of RTOS. It manages the CPU scheduling process and the management process, memory part and the task specifications. So everything is under the control of kernel. And then scheduler, so it decides which task runs next. So the scheduler part is very important, and memory management already discussed in the previous videos. And interrupt handling allow the processor to respond immediately to external events. So RTOS handles interrupt very quickly to avoid system delay. And then we move to the task management part. So tasks with priorities, which is executing first and which is the second position and third position. So everything under the control of task with the priorities and the context switching. Then there is RTOS switches the CPU between tasks. So this process is called as the context switching. That is RTOS save the current task state and load another task. So this allows multitasking, meaning multiple tasks run seemingly at the same time. So that is the context switching. Then we move to the scheduling in RTOS. Preemptive scheduling and the cooperative scheduling is the two types of scheduling part. And then the inter-task communication, we move to the next part. For example, semaphores, mutex and queues, events, these are the examples of inter-task communication. Then the application part of our RTOS, automotive, medical system and industrial aerospace. So here I have to give some more applications in this real-time operating systems. Popular RTOS, that is the free RTOS. It is used for open RTOS, used in many embedded systems, and VxWorks that is used in the aerospace, defense and robotics. So here they are used. And RT Linux, it is combines Linux with real-time capabilities. And QNX is a highly reliable RTOS that is used in the automotive systems. At the conclusion part, in this video, surely you should know about the real-time operating system and the architecture and applications of real-time operating systems. It is reliable in real-time systems. And thank you for watching this video.